There we go. Hi, people. Welcome, welcome. Let me close the advertising before we have to pay something. Hi, how are you? So nice to be here again. I hope you are happy. Christmas is coming. Halloween is far behind. What is Halloween? Nobody cares anymore. Santa is coming to town. That's it. November is here. This is very fast. Hi, Internet. Welcome, welcome. Nice to see you there. For me, you are kind of a black circle, but there you go. Hope you are having fun. Everything should be up. If not, you will tell me, but should be video and recording and everything. What a class we have today. Oh my God, people. I'm not sure how we are going to be doing this. Too many things. I think it's too much fun for you. I'm not sure if you're ready for this too much fun. You may have a seizure of seeing too many things together. So we are going to start class number 7, Lateral Movement, Virtualization, and Threat Intelligence. You can see the amazing image done by Fermín Valeros. So nice. He spent a lot of time in each of these ones, and we love them. This is just for you, exclusive. You cannot find this on eBay. The one where we are attacked, but we get intelligent about it, that it's November the 7th. You have the credits. I think we are not missing anybody. And also, remember that apart from us 7 here, we have an amazing video team there. Thank you very much, guys. They are doing a lot of things for us, like putting this ridiculous stand in the middle of the class and not complaining. Thank you. And look at these cables. Like, yeah, thank you very much, people. So you have the links for us. Go there. You can find everything again. And we are going to start with the results from the survey of the last class. So we have some people here sitting CTUs and online. But we would like to remember you that we take this seriously. The more feedback you give us, the better. It's not only for us, but it's going to be for you and in the future. So take 1 minute and take the feedback at the end of the class, especially you, Internet. You can take the feedback even if you are looking at this video in a week. We don't care, OK? So just go there. So we have the how much you can follow the teacher, some 10s and 9s and 8s and 7. So we are going to be taking a different approach this class about following and asking you how this is moving, replicate what the teacher showed in Drive. There is like a lot of things that are very hard to reproduce, so we are working in this one too and making sure it's better. Thank you for the feedback. And then we have some Parish notices. The assignments 2 to 5 end today, right? Today, still today. So if you didn't do the assignments 2 to 5, please do. These are for your credit points. Without credit points, you cannot approve the class. So go and do them. If not, ask us, OK? CTO students, the class of November 21 is going to be in room E3191 here. It's like a one that is 1 floor up, OK? Do not come to this room. There are going to be, I don't know, something else, RoboSocials, right? The competition of robots is super awesome. Maybe you can go to that one. If you didn't go, you can go. RoboSocials is very, very nice. So November 21, remember to go to the other room. For online people, it's going to be exactly the same. Video, links, everything the same, OK? So feedback about the class, how to follow, adjusting the content for this class so you can have more space for the hands-on parts. We are going to be revising some of the classes because there are too many things. So that is how we are dealing with these ones. We are going to also try to automate more. We already do some automation. In case you want to know, like we are automatically checking all the commands in this document to verify that they work. It's kind of a weird thing because it's a Google document. But that also is going to help us be better. And reminder for you, if you need any help, you can contact us in Matrix, in mail, of whatever you need, OK? Then remember, this is for you.
Yeah, sorry about that. If you fill the, is this working? I don't know. If you fill the feedback form and you tell us, I cannot find this, we cannot help you because the form, feedback form is anonymous, OK? So if you really need help and you want an answer, you have Matrix, you have email, you can your private groups. There is other ways, but the feedback, we cannot know who you are. So if you tell me, I cannot find this document, I cannot find this lab, or I cannot access the Docker, I don't know how to help you. We don't know how to help you, OK?
So Pioneer prizes for assignment number 6. We have the beautiful third prize, mini electro stargate kit. This is beautiful. A lot of pieces for you. Is here, is ready for learning. And the third place is going to go to David Costada, to B4M. David, congratulations. I have to say that the last one was a nice assignment. I'm not sure if you play, if you had fun. We had a lot of fun watching you play. Congratulations. Weird assignment, nice assignment. I'm not going to spoil if you didn't play, but well done, people. Well done. And the Raspberry Pi Pico, which is awesome, small computer in your finger, as the second prize goes to Luboslav Motoslub. Bravo, Luboslav. Luboslav Motoslub. B4M. There you go. Congratulations with the Raspberry Pi Pico. If you don't know how to use these ones, you can ask us. Oh, they want. Sorry, if you were not here, I don't know. We have to watch the video. No. And the first prize goes to Jan Hoferjan. Bravo, Jan. Bravo. He was ready for this one. Sedwino Xiao. Wow. Such a machine. Well done, people, and so fast. We were very impressed by your solving of this challenge. It's amazing, because for us the challenges are super complex, 20 Dockers behind the scenes, and then you solve it like in 20 minutes. It's, oh, no. Oh, yes. I mean, yes. Oh, no. Yeah. So we are going to get better. So class outline, lateral movement is going to be our first topic, people. Then we are going to go to virtualization, and then we are going to go to threat intelligence, OK? A lot of things to do today. Very nice. I'm super, super happy that we are doing this one. So, lateral movement. What is lateral movement? I have a lot of GIFs, CCs. These are glow-in-the-dark ghosts for Halloween. I'm sorry. Veronica is sorry that these are for the old holiday. She's preparing for the Christmas already, but I have Halloween ones. So who can tell me what's lateral movement? What is lateral movement? There you go, Lukashi. I mean, that's like at least that one, right? Like lateral movement, side to side, from where to where? There you go. That is also, I'm giving you this one. Right? And so I move to a cloud computer from my computer here. From my computer, I attack a cloud. I attack google.com. That's lateral movement? And what is then? Within the same network. Thank you very much, Ugashi. There you go. Whee! You have a ghost for you. Oh, we were so good in that one. Wow. We are getting better. So in the same network, you compromise a computer. Maybe you exploit. Maybe you did phishing, whatever. And then you need to move from this computer to some other computer, because you arrive here, but this is not where you're going to go. Maybe you're going to go to the database. Maybe you're going to go to the, I don't know, emails of the CEO or whatever. So every time that in the same network, roughly, now cloud's a little bit weird, but roughly you move from one computer to the other to fulfill your goals, that's called lateral movement. And the attacks are different, like if you are outside the network. That's the big difference, OK? So it's the next step up after you get in. And I would say that if you go online and you find, oh, how is this government attacking, and how is this other government attacking, these APTs, Advanced Persistent Threats, and they do a lot of things, including lateral movement. And some of the techniques that we are going to see today are real techniques used by APTs in the wild, okay? So how do we do lateral movement? What do you imagine? What do you imagine? You're in a computer, in a network, and then you have to jump to another computer. What do you do? Huh? You scan, and then still you are not in. And after scanning, I know you know, yeah. You can access, for example, by well, all the techniques we saw so far in the class, right? So you can brute force, you can, I don't know, go and do social engineering. I don't care, right? Like whatever way that we saw already, you can use the same. So yes, for example, you can brute force, you can exploit a service, like you can go and attack the web like we will see later. You can do a buffer overflow exploit or whatever. Also, you can sniff in the network because it's a local network now. So maybe the people is talking there, maybe you see computers, you find services, you find cameras, stuff like that. So sniffing is a big part. You can do man in the middle. Man in the middle is like when man, woman, it, computer, bot, in the middle, it doesn't matter. When you get in the middle of a conversation that you should not be there, okay? So somehow you manage to be between the server and the client, between the proxy and the computer, between the CEO and some employee reading emails. Anytime that you're in the middle of something that you should not, man in the middle, and this is a very big technique, very big technique. Poisoning attacks. Poisoning attacks is messing with the protocols, right? Messing with the cache, messing with the proxy, messing with the DNS database. So in a way, you are forcing them to connect to you, right? These two different type of attacks. And also memory search, because you are in a computer. So this computer actually has stuff, has users, passwords, whatever. So why not to search in this computer? If this is a window, you can use Mimikatz and others, get the credentials from memory. These are very straightforward techniques, and every attack that goes into a network ends up doing some type of Mimikatz, and then some lateral movement, some persistence, and then trying to go command and control and the rest, okay? A special mention about LOL beans. We saw this last class, do you remember LOL beans? LOL beans, LOL is coming from living off the land. Living off the land is the concept of not bringing your own tools. If you get into a computer, do not install your own malware, because it's easy to detect and it's your malware. It's going to point back to you. So the best ones is just exploit an attack with whatever tools you have in the computer you get in. You have PowerShell, use PowerShell. You have Python, do Python. You have beans, use the beans. This is incredibly hard to detect because there is no malware. There is no nothing. There is no Trojan. There is no virus. It's just people typing. Okay? So living off the land is a huge technique, especially in state-sponsored attackers. So we are going to be doing one of these ones, and we are going to stand with a hands-on man in the middle of an FTP connection. You are going to be doing an attack, poisoning cache attack, where you get in the middle of a connection, forcing two computers to connect back to you, okay? So how does it work? We are going to have the attacker's computer, that's going to be you. Then you are going to be in the middle of a victim FTP client. In this case, in CheveUT, it's going to be you. In the case of online students, you're going to have a special Docker in the Strato CyberLab. And then you're going to have a victim FTP server, okay? So the idea is that you have an FTP server, you have an FTP client, the client connects to the server, but these are not your computers, so you don't see that. You're in another place. And then we are going to be forcing this communication to go back to your computer, okay? Perfect. So it's going to be complicated. What we are going to be doing here actually was not tried before in this scale. So we are going to be talking about computers. Be mindful and keep in mind what is what, okay? I'm going to repeat. We're going to have a victim FTP server. This is going to be each of your computers in CheveUT. For online students, it's going to be when you start the class number 7 here, Strato CyberLab. Yeah, this is too much, but if you start the class, you are going to have 2 Dockers with you. We are going to be connecting to them soon. One is going to be the FTP server. Online is going to be this IP, 172.20.0.110. The victim FTP client is going to be each of your computers here in the university. For online students, it's going to be another Docker in the CyberStrato lab. And finally, the attacker. Okay, 3 computers. Again, in CVUT, you are going to be playing the 3 roles from your Dockers, okay? In the Start Cyber Lab, you, the attacker, is going to be your main shell. This one, the Hacker Lab, is going to be your attacker shell, okay? Then, the attack is going to look something like this. Each of you are going to be an FTP server, right? Imagine you're this one. So somebody else is going to FTP access you because you are an FTP server. And you, at the same time, are going to be an FTP client to some other's FTP server. So we are going to be doing kind of a circle of computers connecting one to the other, you to me, me to you, you to, okay? Everybody's an FTP server, everybody's an FTP client. On top of that, we are going to be attackers. So as an attacker, this computer, see, is a client to this computer, is a server, the green line, to this computer, but it's going to be an attacker, the red line, intercepting these two. Complicated, right? So you're going to be like, oh, I'm connecting here, somebody connects to me, and I'm also attacking those 2 computers. So let's see if it works. If demos are hard, this one is going to be extra hard. It's going to be 80, maybe 100 Dockers attacking, infecting, poisoning each other simultaneously in kind of a dance of packets. I'm going to call it a dance of packets. So we will see how it works. If this is true, if we manage to do this, everybody poisoning each other, 100 Dockers, I consider this the poison más grande del mundo. That's how I consider. Sorry, I don't speak Portuguese, or I'm not Brazilian. But when I want to say this, I just kind of merge into Portuguese, and I have to say, the poison más grande del mundo. So that's what we are going to be attempting here, and see if we can do it. So let's start. Are you ready, people? Yes, yes, no. What are you talking about? Is also an option. Client, victim FTP server. So first step, let's set up the victim FTP server. And for that, online students, please start the class in Start Cyber Lab. And you, online students, are going to SSH into your FTP server. So if I go to Start Lab, click here, it's asking me, do you want to connect? Yes. Which is the password? Admin is the password. Now you are inside the Docker that is going to be the FTP server for online students. For everyone here, you are going to be in your Docker. So give me a second. Online students, you need to install the FTP server. That's the BSFTPD. Maybe it's already there. Yeah, it's already there, so that's fine. Oh, I'm impressed that the document is so large and so many people that it's taking like 1 second to do the alt tabbing. And now, this is only for the online people. You need to edit the configuration. Online people, please edit the configuration. And when you search for write enable, online people, write enable, you need to be sure that here it says yes. So you uncomment the write enable. Okay, people online? Uncomment the write enable. And
sorry.
Wait, no, this is yeah, I missed something here. Yeah, after this is for everybody.
So the online students, sometimes it takes a bit to start all the class, so they need to catch up. Okay.
Yeah. So give me a second, because after this, yeah, should be all of us. So let's repeat this part, all of us. Sorry? Refresh the document. Oh, to see this, you mean? Oh, okay. Well, if you don't see that, all of us, you can believe me, now all of us in CVUT, let's do this in your Dockers. Let's install the BSFTP. So I'm going to be here with you. This is your Docker. apt install BSFTPD. There you go. I have it installed, but probably you don't. Okay. After you install it, you edit the configuration. The configuration is etc/bsftpd.conf, so please edit the configuration. And again, if you search for write enable, it should say yes. So please uncomment the part that says write enable. Okay, everybody? And we just restart the FTPD with the etc init bftpd restart, and now the FTP server is running your computers. Okay? There is an error when you start it.
Okay. Yeah, so we are troubleshooting some possible errors online.
Okay. So for me it worked. I don't know. Yeah, and it's open. So if you have that warning, I think it's going to be fine. So now that the FTP is running, we need to add a user.
Sorry, is it running for you here? Yeah?
Yes. We need to add a user that is going to be a user in your system, because we need somebody to log in the FTP server. And that's going to be the user Pepito. So in this line, we are using user add. -m means create the home directory. And then we are doing $&, which means and. So this is one command. And if this command is successful, and also do this command. And this command creates a password for the user Pepito. And the password is Pepito, actually 1, 2. It's the same, but 1, 2, or 1, 2, 3 is fine. We don't care at this moment. But this is going to create a user and put a password, okay? So try this one. I already have the user. I go to the Substrato Lab, works for me. Okay, everybody? We have FTP server running. We have a password and a user. Now, let's put some secret file for the attacker to find, okay? So this is going to create a file, and the file is going to be stored in the home of Pepito user, okay? You should have a file there. And then, that's it. In your Docker, you stay. If you're in the Substrato Lab, you can do Control-D and get out of the SSH. So all of us fulfill the first part to have an FTP server running, okay? Now, let's gonna go to the FTP client victim. For the FTP client victim, we are gonna set up a configuration that connects to the server and actually access. So, if you're online, you need to log into the second Docker. If you're online in the Startup Cyber Lab, you need to log in to 108. Do you want to connect? Yes, the password is admin. Admin is the password. If you don't have it here, password is admin. And for the CheveUT students, you don't need to create anything more, but we need to actually select which server you are going to be connecting. If you remember, you now are servers. For the client, you need to connect to somebody else, right? And how do we do that? Well, we actually gonna pair you. So I'm gonna run a script in my computer that is called Python class pair something. Yeah, and I'm gonna put this range. And what my computer is going to be doing is it's going to scan the whole CheveUT network, and it's going to create a pair of computers, and I'm going to share with you so you can actually see. Wait for me. Where is it? I will go to here. So let me share this file with you. And this one is called class 7. Yes, this one. So there you go. If now that I run this tool, if now you see this file in CheveUT, data class 7 who to attack, if you just do that command, cat data class you will see this content. And what is in the content? Let me show you the content. In the content, we have all the FTP servers in our network. So the first column is the client, the second column is the server. So now that we are configuring the client, you need to find your IP in this column, and you need to see which server was assigned to you, okay? You need to find your IP in the client column and see which server was assigned to you. I will give you a second there for CTO students. For online students, you just have the 2 IPs of your client and server, so you don't need to do that. I will give you a minute to find which is the server you need to connect. Find your IP in the client column. See which server was assigned to you. Ready? Perfect. Now that you have been paired with somebody, let's first create a new tmax for your client in CheveUT. Let's create a new tmax for FTP client. There you go. Inside your tmax, we are going to be doing the command of the FTP client. This is going to be a specific command. For online students, you also do the tmax, okay? So you also get in tmax. Now, how does it work? This is the FTP command client. This is the FTP protocol. This is the user Pepito. This is a password. Your IP address is not in the list? Are you a client? Are you a server? FTP server? Is the port open for you, port 21, as a server?
You're a CTO student?
If you see your interfaces, you should have one interface with that network, 172.20. I didn't know that. OK, we are solving it. In the meantime, if you're online, remember to do the tmax. So this is FTP command. Pepito is the user. Pepito12 is the password. And then you need to put the IP address of your server, OK? So let's try this in CheveUT. And I think that for me, it was 172.20.020. OK? So when you press Enter, you should have your FTP client connected. Ta-da! You connected with FTP. Be sure you have that working for all of you. Online, you do the same, but you connect to the address of your FTP server, which is 172.20.110. And that online also works. If you do ls, you will see the content. So you are logged in. You can see what's going on in there. OK? Work? Yes? Perfect. How do you get that file in FTP? Well, you get it with the command get. So you get secret.txt. You press Enter. Now you transfer the file to you. And now you can actually Control-D to get out of this FTP, or Control-C. No, Control-D. So you get out of the FTP client. OK? And now you can check that you have the secret file, cat secret file. So all of you should be able to FTP, get in with the correct password, and then retrieve the file. OK? Work? Yes? No? Online people? Do we have some online feedback? Working, not working? Yes? If you follow like I did online, should work for you. Perfect. Now you list the files, you get the secret, and you got out. Super good. This is working. This is working, no issue. If you are curious about the attack we are going to be doing later, which is with ARP, you can use the command ARP-AN, and you can hold this for the future, but you will see the MAC addresses of the computers that you are related to. And the attack is going to be related to this later. It's not necessary, just if you are curious to know. So, now that we are here, we need the client to kind of continually connect to the server, because we are going to be attackers. We are not going to be in the client anymore. We are going to be attacking now. As attackers, you cannot be at the same time attacking and clicking enter in the FTP client. So what we need is your computers in the role of FTP victim client to be continually connecting to the server. So then later, when we are the attacker, we can read this communication. Do you follow? Yes? Online is the same, okay? So for the online people and for you, you need to do this command. The password was 12 for me. So you just do this command, and you put the IP of your server. In my case, it was 20. So you press enter, and what we are doing is a simulacrum of an FTP client just connecting the whole time. Imagine a file transfer, imagine a backup, imagine a cron job. It doesn't matter. Something that is going on behind the scenes. Okay? Everybody? I will also do it here, but the IP is going to be 172.20.0.110. Okay? Now, get out of Tmax, leave it running, get out of Tmax, Control BD, okay? Control BD, get out of Tmax, and once that you're out of Tmax, we are ready for the attack. Okay? In the case of the online people, remember also to get out of the SSH, so you are back in your hacker lab. Okay? So now we have finally a server. Now we have a client that is continually connecting. What is the attack we are going to be doing? The first attack we are going to be doing is called ARP poison attack. We talked a little bit about this, I think, the second class. How does it work? It works in the same way. In this way, ARP, Address Resolution Protocol, is meant to find out who has the MAC address of an IP address I know in this local network. So it's like, hey, I know the IP address 192.168.1.1. What is the MAC address? So you use ARP and you say, who has this IP? And then the computer says, oh yeah, I have that one. Hey, this is my MAC address. So the poisoning attacks works in a way that as an attacker, I can send you a packet saying, oh, you want to communicate with that server? Sure, I am the server. I have the MAC address. The IP address of the server, 192.something.something.10, it's in my MAC address. You are lying here. And then the victim says, oh, thank you very much. From now on, every time I want to go to that IP address, I will communicate with this MAC in the network. That is the attack. And then you will receive the packets, because the packets are going to go to you in the MAC space. And the network, the local network, is going to transfer that to you if you have a switch or something in the middle. Okay, everybody? There are two variants of this. The first one is called ARP reply spoofing. And here, I'm sending an unsolicited, it means you didn't ask before, ARP reply directly to the victim saying, hey, I am the server that you're looking for. That's a nice t-shirt. I am the server you're looking for, and you have my MAC. In the second version, called ARP request spoofing, it uses a type of packet called gratuitous ARP, which is also an ARP reply, but instead of to the victim, is broadcasted, okay? And this broadcast goes the server IP address and the client IP address, but that MAC is the attacker's. Was it clear? I will be honest, a lot of people, a lot of books don't have this correctly, okay? two types of versions. One is called ARP reply spoofing, ARP packet. The other is called ARP request spoofing, but still a reply. Don't ask me why. I don't know. It's an ARP reply. One is broadcast, the other one is not. Okay? We are going to be using these techniques to fulfill our goal. This is how it's going to look like. Okay? These are the differences between the two attacks. Right? So in this attack, you say, oh, I am the attacker, the red one, red attacker, and I'm sending an unsolicited fake ARP reply. This is information. Hey, you want to go to the 111? See, 111? The MAC is going to be my MAC, and that's it. And then the victim says, oh, thank you very much. If I want to communicate with the server, I will send the data to you. And a very similar one happens in the gratuitous ARP, only that the information in the packet changes. Okay? Everybody? Was it clear? Questions? Yes, yes, no. Questions online? No? Okay. So, who are you going to attack? This is getting interesting. For online students, very easy. You have an FTP client in this IP, and you have an FTP server in this IP. Okay, internet? So, for you, it's going to be straightforward. For us, in CVUT, how are we going to be attacking? This is going to be a mess. I got your back. We have the file I told you before. The second list in the file, this one here, is the pairing of you as an attacker and which source IP and destination IP you should use in the command. Okay? So again, search your IP in the first column, and you were assigned these two computers as the victim source IP and the victim destination IP. So I will give you some time. Search your IP. In my case, it's 14 and 19. We are closing the round of attacks. You got it? Online, you have everything done. Perfect. Remember those IPs. Remember. Now, before doing the exact attack, is always a good practice in cybersecurity. You are going to be cybersecurity professionals. Always capture your traffic in these situations. Like, it's a very good practice. Stuff will go wrong. You have no idea what's happening. Maybe the server is answering to you. Just capture the attack packets, and you will see later, okay? So, all the students online and in here, we are going to be creating a new TMAX. I'm not sure if I am inside the TMAX, so maybe you need to get out of the TMAX. No, I was not, okay? Now I'm in one called capture, and now I'm going to be doing this TCP dump. In the TCP dump, we are going to be saying store everything in TMP Poison Capture, ARP, or two conditions. The source host is this, and the destination host is this. Okay? First condition, ARP. Second condition, or something with an AND. Be careful, the parenthesis needs to be escape, so there is an backslash. And in this case, you need this command, and then you put the IP addresses that we said before are for you. If you remember, I think in my case was 14, and the other one was 19, if I am not mistaken. I will check just in case. I will get out. I will check in my computer. And it's for me 14 and 19. Yes, perfect. So I can go back to my capture TMAX. Okay? When you have your two IPs in there, I press enter, and there you go. In the internet, you do exactly the same. Okay? You do exactly the same, but you have two other computers. Let me make this smaller so I can type.
Sebastian, can you make sure you clarify where you are running the command? So this is under Strato CyberLab Docker, not in the FTP server or client.
In the Strato CyberLab is in your main Docker called the Hacker Lab. Not in the client Docker, not in the server Docker. Okay, internet? So for you, it's going to be between 172.0, 108 as the source, and 172.20.110 as the destination. Okay, Internet? So now that we have this, you can get out of the Docker, the Tmax, you can get out. And now we are going to start another one that is to see, because this TCP dump was to store the traffic, which is awesome. But we also need to see the traffic, like with our own eyes. So we need to create another Tmax. I'm going to create another Tmax here. And then we do the similar TCP dump, but without storing the packets. Okay? So we do a similar TCP dump, but we don't store the packets. So for me, it's going to be 172.20.0.14, and the destination 172.20.0.19. Okay? So this is going to be the one that I used to monitor if the attack was successful or not. How do I know? Well, now you see there are no packets. That means we don't see the traffic between these two computers. The client and the server are talking, there is a loop, but we don't see that. As an attacker, this is your normal situation. You don't see other two computers talking. Let's make this happen. So finally, we can do the R poisoning, people. And the R poisoning looks like this. We are going to be using a tool called RSpoof, very, very nice, from the very old DSNF or the SNF suite. And to do that, also Internet, so I can go directly here, also Internet and you are going to get out, yeah, there are some ARPs, that's good. We are going to get out of this Tmax, so go back to your no Tmax situation, also the Internet. And now create a new one for the attacker. We have like 4 Tmax already, right? There you go. I'm going to create one for the attacker too. Oh, I think that I didn't create a Tmax for you. I'm sorry, attacker. And then install this SNF if you don't have it. Yes, everyone install everything. Yes, in their main Docker. The attacker is your main Docker always. Now we are doing the attacker. And this is the attacking command, people. ARP spoof in the Ethernet 0 interface, and it's going to be this FTP client and this FTP server, okay? So we are here. I'm going to put FTP client server IPs. That's going to be for me 172.20.0.20.0.14, and then 172.20.0.19. Okay? Are you ready, people? We are going to press start in the attack. I'm going to give you some seconds while I type also in Strato Cyberlab. 172.20.0.108 and 172.20.0.110. Okay? So if I press enter, this is going to happen in Cyberlab. If I press enter here, you will see your computer sending these fake attacks to the client, saying, client, I am the server, or whatever they say in their voice. So we have an attack going on. How do we know if it works? Okay, get out of your Tmux attacker and go back to your Tmux monitoring. Get out of your attacker Tmax and get in your Tmux monitoring. And if you go in there, you should see traffic. See? We have traffic, people. Success! Attack! Hackers! We're hackers. That was a nice attack. So can you see the attack happening? Oh my God, people, you know what this is, no? The poison mais grande do mundo is this one. 80 Dockers poisoning each other in harmony. They are even happy to do this. So, and you can see from time to time that you can see, yeah, I'm gonna see quit, you can see quits and stuff like that, right? So how do we get information? Okay, you can get out of your attacker dockers. I'm gonna get out of here. And to check if you can find information, you can do strings. Do you remember the command strings? Just gets into any binary file and extracts the ASCII characters. So you find the strings inside the file. Very useful, especially in CTFDs. So if you do this command in outside anything, you will find users and password, people. Did you see that? So what I'm doing is going to the pickup and just saying, I don't care about the packets. Who cares? Just give me the strings. And because FTP is a string protocol, ASCII protocol, we see user and passwords. Do you see that? Woohoo! We just stole users and passwords in an R poisoning attack in a local network. Wow, that was a trip. So, how do we abuse the credentials? And you can also do the same here. I think that I'm not sure if did I do the attack here? So we have rspoof 1 and 10. And what about the SSH? Should be 108, yes. So let me check my tmax. Should be here, poisoning like crazy. FTP client, yeah, it's poisoning like crazy. And I'm here also poisoning with the attacker, right? 110 is at 20.0. And TMP poison, do we have something there? TNT, let me check if it worked online. I think it didn't. Oh, what's going on here? Oh, let me do the TCP dump again, just in case to check. Something happened online for me. Maybe I mistyped some IP addresses. Sorry that I need to do this, but it's too small. The source is gonna be 172.20.0.108. The destination is gonna be 172.20.0.110. Oh, I see stuff. Oh, I think that my TCP dump was not working. But yeah, the attack also worked on the Cyber Stratolab. If you did everything correctly, you should see here the user and passwords, okay? So, perfect. Now, how do we abuse it? Well, as an attacker, finally, you can take this information, wait for me, here, abuse. You can take this information. If you don't have the FTP command online, you can install it. You don't need to do this in CVUT. Yes, install FTP. And you just now use the FTP command, the one you just learned. So you say FTP, Pepito, Pepito12, and the IP of your server. As an attacker, you were not able to do this before. So 122.20.0.20 for me. And that's it. As an attacker, now we have access to the FTP. Was it clear? Yes? Questions? What happened? Who we are? Where are you? Why are we here? What is life? Online people? Do you have questions? Did it work for you, online people? Some people say yes. Perfect. That was our first attack, people. Wow. Well done. So let's clean up a little bit for the second attack. If you are online people, you first get into your FTP clients. If you are in CVUT, just go to your tmaxes and stop everything, people. Okay? So go to your tmax clients, stop the while, and Control-D. Go to your monitor, step, Control-C, Control-D. Go to your capture, Control-C, Control-D. Okay? Go to your attacker, Control-C. Wait a little bit. It's going to re-ARP, and it's going to fix the tables, because if not, the computers will never talk again. So you have to be nice. See, it's like fixing the IPs. And now get out, okay? I will give you 1 second for you to do these cleaning ups. I will clean up in my Stratos Cyberlab. Attacker. 0. Get out. Stop attacking. Perfect. Yeah, and also I need to SSH back to the client. And yes, yes, admin. And we had so tmoxes in here. I think 1 FTP client. And I'm going to stop it. Okay? Everybody? Did you clean? Perfect. Let's move to the next. If you have issues with your tmax, there is a tip there if you want to solve it. Now, yes.
If you're trying to capture packets, mostly for the internet people, and you see an error TCP dump not found, is that you are in the wrong Docker. When you do hostname, should say hacker lab, and then that's the server where you should run TCP dump, okay?
It's very easy to get lost, to have 3 different computers in the first exercise only, so it's going to be a tough one. Questions? No? Was it clear what we did? 3 computers, sniff the traffic. This technique is very powerful, people. You can go to any network, coffee shop, and you can do, sorry, I have a thing in my, sorry. You can see if you can see the traffic of other people. No issue. It's like straightforward. 2 advices. The first one is attack 1 by 1. Do not air poison the whole network because it's going to be a mess. First, you don't have the bandwidth. You would have bandwidth of 20 computers going through 1 computer. It's not going to work, which means everything is going to go down. Nothing is going to work. And then, yeah, we have an issue, okay? And always remember to stop slowly their poisoning so you heal the network with the correct addresses, okay? Be careful with this technique. If you are in a weird situation, if you don't know what you're doing, you can be in trouble. If the network stops working, yeah, okay? Questions? No?
Yeah. I have 2 questions from the internet.
Yeah.
So when you were showing with the strings and the users, Pepito, 123, etc., before the user or pass, there were like weird characters like Y, Z, exclamation mark. Do you know what they are?
Yes, that's because actually I said that FTP was an ASCII protocol. That was a lie. I'm sorry, I lied to you. That was simple. It's not. It's a binary protocol. So there are some parts of the header that are for the FTP protocol itself. And then there is the part that you send as a human that is ASCII. So those binary parts, the same with Telnet, is a binary protocol. They show like weird characters in there. Yeah.
And the second question is, what is the difference between performing this attack and just opening Wireshark and sniffing the traffic?
So the difference is that if you open Wireshark and you sniff your traffic, like we did in TCP dump, you don't see any packets. You know? Because Veronica computer is talking to Muri's computer. Those packets are not coming to my computer. They are separated. The Wi-Fi router, the switch here, even if you use cable, splits the traffic in the layer 2, so the packets go between these 2 computers. This is not the 80s anymore, so I don't see those packets here. To be able to find those packets in my computer, I need to trick them with the air poisoning attack. Okay? If you go to a coffee shop and you start Wireshark, you will see your traffic, some broadcasts, some multicats, and that's it. But if you do air poisoning, you will see the traffic of a phone going to the internet, for example. Okay? Perfect. So let's continue. Second attack of the day. Hands-on poisoning NBT-NS attack. Wow, that was a mouthful. So what are we talking about here? First, we need to talk what is SMB, Samba, NetBIOS, and NBT. These are all protocol names, and let's go one by one so we are not lost. The first one is NetBIOS. NetBIOS, the Network Basic Input-Output System, is a very old, it's actually an API, it's not even a protocol, that allows certain software to actually communicate to each other. what you can do with NetBIOS is find the name of a computer and get the IP address. Rings a bell? Which protocol is usually doing this? I have a name and I want an IP address. DNS, right? So NetBIOS can do this. And also you can provide sessions, which is authentication and login, right? You can actually, work in many legacy systems. And why? Why would we have NetBIOS if we already have the internet and TCP/IP? Well, because NetBIOS was created in the same year as TCP/IP. This is like very old people. Like when NetBIOS was created by IBM, there was no internet, there was no TCP/IP. So they, hey, we have a bunch of computers, let's connect them. So it's like, yeah, that's it. It's the best they could do. I'm impressed it still lasts so long. So this is the basic API protocol we are going to be using, NetBIOS. Now, because it's this very old, then we actually put the internet and the normal Ethernet network connections in below. So when you're using NetBIOS over TCP/IP, we call it NBT, okay? NBT, what we are going to be using in this class, is NetBIOS on top of TCP/IP. The usual ports are 137, 138, 139, stuff like that. This is very old, people, like NBTs, again, from the 90s. But now the new version, let's call it that way, SMB, uses port 445. So what is SMB? SMB is the server message block, and this is a real network protocol, the traditional protocol used by every Windows computer ever. This is a protocol you use to share files, find printers in your network. I want to send you something. Whenever you do this in the Windows computer, when you go and you see, show me computers in my network, all that protocol is SMB, okay? It's the most used protocol in local networks in corporate environments by far. And finally, NBT-NS is the NBT name server. It's kind of the DNS that we were talking before, but in NBT with these Windows computer names. Okay, everybody? Question time? Perfect. Now, what are we going to be doing here? What are we going to be showing? It's a little bit advanced. This is a real technique that if you go to the internet and search, how do APT attackers from this country get in? This technique we are going to be using is still in the top maybe 10, maybe 5. It's very powerful, very hard to stop, and we don't know how to do with this one. So it's going to be a poisoning attack now on the NBT name service protocol, not in IRP and NBT. So we will listen to broadcast name requests that are going to be broadcast. We are going to be listening to these ones. And then again, we are going to be answering, oh, you want to go to the computer super server? Sure, sure, I am the computer super server. Give everything to me. Okay? It's going to be a poisoning attack, man in the middle, based on the NBT-NS poison. So, why does it work? Why does it work? This is important. This attack, to be successful, needs errors from the human. You cannot just do this like an ARP. You need that computer, the victim, to actually make some mistake while typing the name, while typing the IP address. Maybe the server that is trying to go is down. You need some special situation, so this is broadcasted by Windows. It works like that. If you're in Windows computer and you put / server database, and that exists, you just connect directly there. The attacker cannot stop you easily. But if you mistype, or the computer is down, or the IP address changed and you didn't know, then Windows automatically will ask the broadcast network, who has the database server? And then you as an attacker say, oh yeah, I am the database server. And you are in. You will be surprised how successful this is. This is, I mean, you go to a corporate network with Windows, you do this attack, and you would have thousands of people connecting to you. It's like stupid. So This is a diagram how it works. The normal NBT operation is you have a client, and the client says, oh, sorry, NBT name query B, right? I want to talk to B. This is the B server. And you send this broadcast. And then NBT says, oh, yeah, I'm here. Perfect. In the attack, now we have an attacker here. And in the attack, you say, hey, name query BB. Oh, I make a mistake. Instead of B, I'm asking for BB. And then the attacker E receives this and saying, sure, sure, BB is here. You got it? Perfect. Now, how are we going to abuse this second exercise? With a tool called Responder. Responder is the preferred tool for penetration testers to go and get this in a local network. Responder can do a lot of things. I'm not going to go into all of that, but you can do the NetBIOS name service attack. You can do local link multicast name resolution, broadcast and multicast requests. You can do the WPATH that we saw the first class from Windows. You can even do in Chrome, when Chrome boots up, your browser is asking 3 random domains, checking if there are wildcard domains in your DNS server. It doesn't matter. It's asking 3 random domains. This tool can pick that up and say, yeah, I am one of those. So you can even do this to Chrome browsers, no issue, OK? So we are going to be needing for this exercise an SMB server. We are going to be installing now. SMB client, we are going to be using 2. And the attacker. As before, 3 computers. Before going there, it's time to take a break. So we settled ideas. We are going to be doing a 10 minutes break, and we are back in 10, OK? So at 41, we restart, OK, Internet? 10 minutes, go get a beer and back. Maybe 2. Well, why not? Coffee, too. Coffee, 2 coffees. OK, ready, people? And see that there is limited edition new stickers, shiny ones, with llamas and unicorns. So, just saying. OK, people, let's continue. So far, we did an attack in FTP, and we are preparing to do our second attack in NBT-NS, the name server. So, what does it mean? The first thing, remember, we need is our Samba server. The second is our Samba client. And the third one is going to be our attacker. OK? Samba server, victim, Samba client, victim, attacker. I can repeat that if you want. So let's install Samba. But in case I didn't say it, that I think I did not, Samba is the SMB protocol version of this protocol for Linux, OK? When the Linux computer started to be connected to the SMB, they created a program called Samba. So let's install Samba because we are using Linux. If you are online, you need to connect to your victim server. If you're online, victim server. So in your Strato Cyber Lab, you connect to the computer 110. Yes, you want to connect. Yes, admin. You are going to be installing the Samba server in this Docker. For CheveUT students, no. You are going to be installing the Samba server in your normal Docker. Everything happens in your normal Docker. So, everybody, apt install samba-y. Please do this one. I will do also here. We are going to install Samba. It's going to take some time. OK? Perfect. Now, for CTU students, we just put the whole configuration for you ready. You just need to copy it from /data smbconf. So CTU students, you need to copy the configuration directly in it Samba, and you are done. Ba-bam. I will tell you later what's going on there. If you're online, we need to delete the old configuration because it's horrible. So just delete the configuration. And now you need to create the configuration. So edit this, right? You can do like this one, and this one. And then you need to put stuff inside. And online, what you need to put is exactly the configuration we are going to be using. So you copy from here, you go to your file, and you just paste everything, okay? Online, you need to copy paste the content in your file. If you're in here, you don't. So what is in here? Well, we have the global configuration of Samba saying the work group is going to be called Evil Corp. The work group is a logical grouping of computers in a local network. So Windows, or SMB in this case, they allow you to separate the computers in groups. These are called work groups, okay? Then it's going to be the name of your computer, in this case, AD server. We are going to be using security user, which means ask for user and password. Then we are going to say, if you don't have a good user, just you're going to be a bad user. So no user, bye-bye. We are going to be disabling the printer, spool SS, disable yes. We don't want printer sharing here. And then we are going to be, very importantly for the people in CVUT, changing the default port from 445 to 4445. We are doing this because in your Dockers, you're going to have Samba, but also Responder, and they both want to use the same port. So to avoid that, we are going to be changing the port. And then we are going to be sharing a resource. The resource is going to be /server Samba share. It's going to be not read-only. It's going to be browsable, so you can see. It's going to not allow guest users, and the only valid user to log in is going to be Pepito. Okay? This is a super configuration of your Samba. So now that we have the configuration, you need to add the user again in your computer. You may have the user in CVUT because you already did this. So if I want to do this in CVUT, Pepito exists, it's fine. But I have, sorry, I don't know why I put 1, 2, 3, but yeah. But if you do this in online, you need to create a user. You are in your SMB server victim Docker, and now you're going to create the user. I already have it because I already have before. Yes?
Question from the internet. There are 2 victims, right? One server and one client. Can you repeat that?
Yes. There's going to be a SMB, the Samba server victim. This is the computer with the resources. This is the computer with whatever data you want to access. And then there's going to be the client, the SMB client, that is the poor person in the network that is usually getting into the server because they have to work, I don't know, send an email, print something. So there's a relationship. The client and the server are both good, both in your network, you know, somebody working. And then the attacker that is going to intercept this communication. Okay? Clear? Yes, everybody? Perfect. Now that we have the configuration, what we need is to create this share resource, because we said that we have the resource, but we didn't create it yet. So you need to create this mkdir. I'm going to create also online. And then you make this folder belong to the user Pepito and group Pepito. Remember, Pepito : Pepito means user group Pepito. Okay? Now SRV Samba share will belong to the user Pepito and group Pepito. And finally, we need to give permissions to, you can also do without the 0 because it's complex. We need to give permissions, which means 7, read, write, and execute for the user, 7, read, write, and execute for the group owner, 7, read, write, and execute for the rest of the users of the world. So this is the most open, dangerous configuration ever you can have. It doesn't matter right now because it's not necessary, but it's going to work, okay? Both in Ceratolab and in you. Now, the next step is, remember we are setting up the Samba, is to create a Samba user. Confusion here. Pepito is a user in the operating system in Linux. But remember that Samba is its own system. So Pepito does not exist in the Samba system. we need to create the user inside the Samba system. And for that, we do SMB pass WD-A Pepito. Important is that that password should be test12, because we are going to actually try to find it. If you put something more complex, it's going to be very hard. So you create a user, and then the password is test12. Test12, enter. Test12. Test12, enter. And I will do here again. Test12, enter. Test12, enter. Be sure you put it correctly, because if not, somebody else will not be able to attack, okay? Now that we have the user created, we are going to create our secret message. We are going to put this in the Samba server. Oh yes, the messers become the messies. And there you go. In Strato CyberLab 2, we have this secret message. If you don't know the reference, you can find it online. And now we restart the Samba, okay? Restart the Samba. Everybody, restart the Samba. And finally, your Samba is ready to be attacked, okay? Now, if you are CTU students, right now, you can share your IP in Matrix, and you can say, hey, I have a Samba server. I would like to be attacked. We don't need the list for this, so please get your IP, go to Matrix, and say, oh, hi, everybody. Can you please attack me? If you are online, you don't need this, because you know the IP address of your server. In CVUT, you need to find somebody else's server. So please get your IP. Mine is 02, and I'm going to go to Matrix, and I'm going to say, I'm not sure, in general, live questions. How do we do this? Live questions. Hi, this is my IP. Please attack me. Attack me. Okay? There you go. I will give you some minutes to do it. CTU students, yes. I mean, if you want to put your IP address being on the internet, you can, but nobody's going to attack you because you are in the internet. Okay? In this moment, the Samba is set up, is ready. We have our IP addresses out there. Let's go to the second step, which is the Samba client, the good user that we are setting up to access the Samba. So, online students, be sure that you get out of your server Docker. Online students, get out of your SSH server Docker. And log in to your other Docker, people on the internet. Strato CyberLab, get out of your 110 computer and log in to your 108 computer, admin. If you are in CVUT, you don't need to do that. You're going to be using the same one. So let's install Samba client. This is for everybody. Everybody install Samba client-I. Also here. Install it. Okay. Waiting for you. Now that this is installed, and you already pick up some server from the Matrix users, do you have any friend that you can attack because you are very nice? This is the normal client of SMB. So it's going to be SMB // the IP address of your server, and then the folder where you're going, share, and then the user Pepito, and then the port 44445. So I'm going to pick somebody from Matrix. I'm going to say, oh, here, for example, I have the 092 of Shimon. So I'm going to go, oh, 092. Let me see if I can attack. 172.20.092, right? And it's going to be ask me for the password. The password is test12, and I'm in. Ta-da! Now, as an SMB client, I'm able to connect to an SMB server. And you can do ls, and you can do the secret file. Nothing fancy so far, no attack. This is your normal SMB connecting to your Samba server. Okay, everybody? Did it work? Second step. Do you have a working SMB client? I will, in the meantime, while you are continue typing, going to do it in my 172.20.0. And it's going to be test 1, 2. Also working in the Strato CyberLab. Questions? Anybody lost? Anybody found? So good. Let's continue then. You saw the secret, you had the secret file, perfect. And you can also try a bad password just to be sure that this is not a trick, that if you don't have the password, you don't get in, okay? That's something you can do. Now we are ready to do the attacker, people. We are ready to do our attacker in SMB. So, online students, please get out of your FTP server SSH. Online students, get out of your SSH. Go back to your hacker lab, okay? CBUT students, just stay wherever you are. Now, let's create a Tmax new T responder. Let's create our new responder Tmax. And we are going to install responder. This is so nice. It's a very beautiful tool. Remember I told you. Yeah, I already have it. So let me go to here, Tmax, new T responder. I'm going to clone in Strato CyberLab. Get into the folder responder. And now create an environment, because Python libraries, they only like environments. So Python 3, module, virtual environment. Create a virtual environment called virtual environment. Activate it with the source activate. Wait, so please, I'm going to create it here. Now I will activate it. Okay, it should be activated. And now that we're activated, install the requirements. Okay, install the requirements. Install, 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 install. Okay, everybody? Now, we are going to be one important modification to the configuration of responder, that is auto-ignore after success. So edit the responder.conf and search for auto-ignore after success and put it in on. Because if not, we are not going to be able to share the attack with our fellow students in CBUT. For the online people, you don't need this actually a lot, but it's good if you have it anyway. So auto-ignore after success. Okay, so we are ready to start responder. Everybody? We are in the attacker. We are going to present it in responder. We are going to be responding. So Python responder, and you should see something like that. A lot of nice information telling you what responder is doing, which protocols is actually poisoning, everything. It's poisoning DNS, multicast DNS, a lot of servers, start HTTP, everything, everything. Very nice. We are super happy. So I'm going to do the same in the Strato CyberLab, and it's listening. Remember, responder is a sniffer, okay? It's a sniffer. Responder is not going to do anything sending packets. It's just going to receive. So now that we have the attacker, this is a situation that you got into the network of the company. You got in there, you start responder, you press enter, and you wait. And you wait, and you wait. Now, because we are not going to wait forever, as a victim, we need the SMB client to actually connect to the server in a wrong way, so we can actually capture this hash. We can actually capture the password. We can see the credentials moving. So, for online students, first get out of your responder. Online students, get out of your Tmax responder. And you need to log into your client victim. Online students, log into your client victim. That is a computer 108. Okay? Admin the password. So now you're back in the victim. online computers, online clients, and the online clients, you just do this. Online people, you just do this. SMB client, and pay attention that I make a mistake, and instead of SMB server, it's SRB server, because, so this is the mistake with a B here that I'm doing. And that is gonna force this client to actually ask in the broadcast about this server. The user is Pepito, the password is test12. This is online, but access denied is fine. But because you are a Samba server and because you are already doing responder, you cannot also be the client. So I will be your victim, okay? I, alone, Sebastian in CVUT, I'm gonna run this command that is a for loop to be the victim and ask for computers in the local network. So when I'm doing that, you should see in your responders a message with some hash that has been found. So I'm gonna stop this, I'm gonna go tmux. When you go into your responder, or if you're there, tmux ls, oh yeah, I have responder 12. I have a lot of ignore. I'm not sure if you have ignore. Go up, go up, go up, and see if you have some hash. Yeah, there you go. You should have that. Do you? Do you have the yellow one? Woohoo! Capture! You successfully answer and say, oh, you want to this weird computer? I am that weird computer. And then, okay, let me first see if everybody got it. Everybody? Somebody did not? Yes? No? You don't know what I'm talking about. You don't know what is a hash. You don't know what is the Samba server. You got it. No. Yes. Let's show of hands. Who got the hash? Thank you. Now, who did not get the hash? Look at that. Oh, we have yes, yes. No? Some people on the internet. Okay, let me see the people on the internet. So, if you are in Cyber Strato Lab and you do this, now you can get out of the SSH of your victim, because I'm the SSH of the victim, and now you can go back to your responder thingy, and you should have this on the internet too. If you do not have this on the internet, it may mean that your client, when you put the SMB there, it's not sending correctly. So try to put any other computer name. It can also mean that you maybe did not install responder correctly. If responder is correctly in the Strato Cyber Lab, you should have something like that. Okay, everybody? Yes? Now, people, we capture a hash. Do you see the hash? It's weird, right? We don't know what is a hash. So this works like that. This is the user that we just intercepted. This is the work group. This is the LM hash between these columns. This is the NTLM version 2 hash, more advanced hash, and then a blob that we don't care. So what do we do with this? We are attacking here. We are trying to do lateral movement. What are we doing here? Well, what we do is we abuse this. How will we do? Yeah, you should have something like that. Yeah. Oh, yeah, how the attack works. I can tell you a little bit how the attack works. If you see in my screen, you will see that there is a NetBIOS name service packet saying name query, who is computer 10, right? Looks like that on Wireshark, right? Who has ta 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 ta. And then the attacker says, oh, sure, I'm going to send you a NetBIOS name service response saying computer 10, yeah, it's this one, it's the 02. This is the attack. Okay? This is how it looks like in the network for you. Now that we have the hash, how do we use it, people? How do we make the attack? 3 main ways of being the attacker here. The first one is, let's crack the password. Who can tell me, and I have because it's a ghost. Who can tell me what is to crack a password? Internet, if somebody internet asks, I'm going to drop this into the camera. Very well. So you have the hashing algorithm you need to know, and then you are trying different inputs, and you hash them until the hash you are generating, cracking, it's equal to the one you got. And then you know. It's called brute forcing. There are many ways of brute forcing. Are you ready? 1, 2, 3. Whee! Be careful. Oh, there you go. I'm getting very good at this. Sorry. Rainbow table. What is a rainbow table? I have a ghost for you. What is a rainbow table? Perfect. So, yes. So here it says a rainbow table. I say, what is a rainbow table? A rainbow table is all the pre-computed hashes ever of all the combinations possible in the history of letters, and you create, until some length, and you create the hashes of all of these ones, and then you store. Why would you do that? And there you go. It goes for you. 1, 2, 3. Whee! Be careful. Oh, I'm sorry. Doesn't want to there. So why would you pre-compute the rainbow tables? You want to save time. True story. So if you want to brute force the hashing, it's very slow. But if you pre-compute the 1,020 trillion possible combinations, you just do a search one-to-one. You say, OK, give me this hash, and that's it. Literally takes the time of doing one search. The problem is computation and storage of this. If you want to compute the hashes of something like 8-character passwords, it can take 4 terabytes. That's it. So you want to have 12-character passwords, 8 terabytes. Do you have an 8 terabyte disk? I can give it to you, no issue. So actually it's an issue, and the people is copying this one. So rainbow tables, much better. Oh, what happened? That was weird. So now that we have this, we can crack it. That was weird. The second is pass the hash. Pass the hash means once I have the hash, I don't need to crack it. I can just give it back to the server. So I try to log into the server, and when the server says, hey, who are you? Tell me who you are and authenticate, I just send the hash. Doesn't work in every protocol, only works in LM, LTLM, a little weird. We are not going to be doing this one. I try, it's not working. There is something at the end of the document about this. If you have Windows computer, it may work, no issue. In Linux, tough one. I'm going to make this higher. The third one is called the relay. Relay is I capture you as a client, and then I connect to a real server. And then I receive from the server the challenge, from the client the hash. I don't know the password, I give it back, but I'm in the middle of the session. And then I'm man in the middle, I can do whatever. So let's do our thing. Let's gonna crack the password. For that, we are gonna be using Hashcat. So we need to install Hashcat. Everybody, please install Hashcat. Get out of here, install Hashcat. Get out of here, install Hashcat. And Hashcat is crazy awesome tool. Very, very, very good. So what we need is to get the hash you found and put it in a file. We just need from the user to the last number at the end, OK? So you go back into your responder. I have it here, mine. I copy-paste my hash. Maybe you already copy-paste somehow. And then I go to hashes.txt, and I just passed my hash, OK? So what you need is this hash in a file. Got it? You have here the format. And this is a command, hashcat. The protocol is NTLM version 2 SSP. And we are going to be specify the mask attack mode. Please put the output in cracked.txt. read the hashes from hashes.txt, and this is the format of the password. The password is, this is a little bit cheating because I expect the password to have some length. If you don't know the length, you can actually try to guess it. But in here I'm saying, this is a lowercase, 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 and 2 digits. Okay? Maybe you know the password because it's forced by the policy. Maybe you know the password because you already crack others. If you don't know, you need to try all the combinations. We are not going to be trying all the combinations because it's going to take time and CPU power. And we only have one computer for 80 crackers. So it's going to be a little bit faster. So when you press enter in your hashcat, please, it's going to be starting, and you have to be patient. It's doing something, GPU, BPU, CPU, and then it's kill. Okay, so I think that we ran out of memory. So yeah, the memory is an issue. It's an issue. So I will do it in Stratolab because it's my own computer and nobody can kill it. So I will go to Stratolab, I install hashcat, and then I will go to my Tmax where I have my responder. I will get my hash. I will copy, copy, copy. I will get out. I will create my hashes.txt file. I will paste it. And now I will do the hashcat in my own computer because it's better. So while you are doing this, please try to again do it in your computers. Maybe you are killed. Maybe you are not, and you are lucky. I'm not sure. Did anybody did it successfully? No? It was killed for everybody? So we can do the following. We can do half of you do not crack. Stop your crackers, okay? No, I have better.
So all of you that are called Martin, you can crack.
Martin's first.
And then we rotate.
Jan's,
yeah.
Then Jana's later. So.
And I have a one better. All women can crack.
And that's it. So let's try half of you. You do not crack. You people are allowed to crack. Are you ready? Let's crack. 1, 2, 3. Tell me what happens. Please be patient. I am patient. Did it work? Are we there yet? Are we there yet? No? You are killed? Ah, not yet? You are killed. Somebody's still cracking? Still cracking? Okay. No, because it's like 500 megabytes of memory only. I check. We should be able to do this. Yeah. Yeah, but in each Docker can crack. I know. Yeah. But the whole computer, maybe. Ah, the computer is fine. And why we are being killed? What? Okay, I'm not sure what happened, people. When I tried with 5 computers, worked perfectly. Nobody finished here? All of you were crack and finish? Okay, let's go one by one. One volunteer. Who is going to volunteer for the cracking? Oh, there you go. So, nobody cracks. Are you ready to crack?
But I still see hashcat running.
Ah, no. Stop your hashcats. You were just killed? Nobody's running? Are you sure? Okay, so wait for it. Stop your crackers.
I still see 2.
2 crackers are cracking. Who is cracking? What did I tell you? What did we talk about cracking? Ready? Okay, crack. At least 1. Oh my God. I did 5, no issue. Internet, you're so lucky. You can crack. And look at this. It was literally, what is that? Like 20 seconds. 20 seconds. This is not hard. So, are you cracking? Okay, let's continue.
Okay, we will look into it.
Yeah.
Also, sorry, there are some hashcat running from the assignments, so maybe that's also taking some time.
Okay. So if imagine this work, so let's it worked. So when you crack, you should see something like this. Oh, sorry. Something like this. That it's, oh, you are cracked. This is a format. Actually, this is the amount of possibilities, which is a lot. That is millions, and it's 45 millions. And then you crack 5 millions, 10%, and then it finished. It was super fast. And then if you do a cut of the cracked files, you should see at the end the cracked password, test 1, 2. I don't know why it didn't work. You can slowly start cracking again while I'm talking, one by one, to see if it works. At the end of the cracking, the multiple cracking, 100 crackers in one computer probably is out of my skills in this moment. One that we have the cracking, people, we have the password. As attackers, after responding, we are ready to attack. So get your SMB client in your attacker. You know your server. You know now the user and the password. You know the password because I gave you, but imagine that you got it from your cracking. So if in Cheveux you are in your Docker, you can now try to log into your server, 172.0.20.0.92, I think it was for me. And if everything goes correctly, oh no, the server is down. Was it 92? Oh, maybe somebody took the server down. Do we have, which other server do we have that I can try? Servers. 58. Sorry. Let me see. Are we there yet? Oh, there you go. So if it worked for you, now as an attacker, you're able to get this hash and crack. People, you make it. This is unbelievable. Aren't you happy? I am happy. You just did a responder tool, which is a very complex and advanced tool, sniffing in your network NBT packets, lying to others, and then capturing the hash. Cracking didn't work, but cracking later the hash will work, and then you have a password, and that's it. You can do lateral movement. You can leave files. You can read files. You can do whatever. So something that we cannot do right now is execute commands in that Samba server, because Linux does not allow to execute commands like that, but Windows does. So if you do this in a Windows network, now that you have the password or the hash, you can execute commands remotely in any Windows, pexec, hash, or password, and go. That's beautiful. And this is how 50% of the APT attacks in real corporations work, okay? So, a little bit of recap while I give you some minutes to finish. Lateral movement is a crucial part of any APT advanced persistent threat attack. It's the preferred tool of pen testers in Windows environments. It's very useful. I suggest you get comfortable with it. And there are many techniques and protocols to do lateral movement. We saw man-in-the-middle with I-personing. We saw poisoning with NBT protocol NS. And you can do many more, okay? So lateral movement, end of the topic. We move a lot laterally. Questions? You manage? In your computer. Yeah, 1 second. How 1 second can be too much for the Docker? I don't know. Nobody could crack it on the Docker? You are so smart. But it worked. Woohoo! I can lie to you and I can say that we put security measures to avoid cracking, but that's not true. Question, people? Nobody? Internet? I'm giving you time to recover, to appreciate the crazy good things you just did. Sometimes it's hard to appreciate because well, the commands work, and you press enter, and it works, and that's it. But if you want to try to do this in another network, in another computer, you will see that it has some complexity. Protocols, versions, timing, who is talking, what are you talking about, right? It's like there are many things to realize in the middle. No more questions? Are we ready to continue? Yes, yes, please, please. Nobody says please ever. Please, more, more. Okay. We are going to continue into virtualization. And we don't have the second break here. We have it in 10 minutes. So keep track. Virtualization. Who can... Huh?
Sorry, what was the question?
Question. Be patient.
Question from the internet. When you use Hashcat, when you use a huge rainbow tables, and the cracking is faster, right? But we don't understand how. Yeah,
rainbow tables, you don't need to put them in hashtag. Like rainbow tables is like a database. So you have the rainbow tables, you have the hashes and the passwords they represent. Or the opposite. So this is a table that was already created by somebody. So you have all the possible passwords ever and the hash. So when you want to crack a hash, you just search that hash in the database, and that's it. It's a one-to-one. So can you tell me the password for the hash ABBB8888CDDBBDD? I said, yeah, it's 1, 2, 3, 4. So in rainbow tables, you just go and get the password directly. It's awesome. Like, how was your name again? You were saying the rainbow table. How was your name again? Yeah, Lucas. As Lucas was saying, if you're cracking often, you want a rainbow table, right? If you go to DEF CON conference in Las Vegas, there is a village, the data, something village, data manipulation, data recovery, okay, some village dedicated to data, and they have machines, hardware machines, very expensive, very powerful, that they copy hard disks at crazy, incredible speeds. So you can go and they have a list, like a menu of all the rainbow tables, and say, I would like this one. And say, okay, give me your disks of 20 terabytes. So the people goes to the conference with several hard disks of 20 terabytes, and you leave the disk the first day, and they start copying, and it takes like 5 days, and at the end of the 5 days, you get your rainbow tables back in your hard disk. It's like so much data that it takes days, and they have a queue of hard disks, it's like 200 hard disks, right? Every year, this is like the spreading of the rainbow tables. Another question? No? Okay, let's continue. What is virtualization? Who can tell me? And I have another ghost, glow in the dark. Did you make it glow in the dark? Yeah. Okay, I like it. So the virtualization is like doing what? Okay, there you go. I like it. So you have multiple things instances, like operating system, programs, whatever. And for each of these things, whatever you are virtualizing, hard disk, space, CPU, they look like all of them have it, but they are virtual, right? Like we can share CPUs, memories, operating systems, networking, databases, the whole computer, it doesn't matter. Everybody believes that they are using that, but actually it's virtual, right? It's like a sharing system. There you go. 1, 2, 3, ready? Ooh, that is, I'm so sorry. I'm so sorry. I try, but they have some wings. It's like, I need to work in the aerodynamics of the thingy. So, virtualization is the process of creating a simulated environment, virtual instance in this case. You can virtualize hardware, you can virtualize software, you can virtualize storage. By the way, peer-to-peer storage, anyone? No? And network virtualization, you can virtualize many, many things. When you virtualize hardware, usually we call this kind of that you're running the hypervisor. So each of these virtual machines runs its own operating system. and using this hypervisor. Classical examples are VMware, Hyper-V, and VirtualBox. You can actually do software virtualization, which means you run isolated applications like Docker. Parenthesis in here, you can also virtualize programs in your own virtual machines. Like, for example, you create an executable, but that executable does not have instructions for your CPU. It has instructions in a virtual machine. So you can, with a program, run another program. And this program has your own instructions, done by me, doing whatever I want. So I create my own virtual machine. This is very common in CTFs, but also it's common in antiviruses. The antiviruses gets a file that is executable, and it's not going to execute in the operating system. That's dangerous. So they run their own small virtual machine interpreting the instructions. That's also virtualization, okay? And then storage virtualization and network virtualization. What about hypervisors? Well, the software running in the real machine, right? And in charge of creating these virtual machines, it's called the hypervisor. And there are two main types. Hypervisors can be of type 1, which means bare metal, like really running on the hardware, really running on the metal. These are installed on top of whatever. There are no operating systems behind them. And they are very fast, super, much better secure. For example, VMware ESXi or KVM in Linux. The second type is called the hosted version. Then this is installed as a separate software layer, okay? Much, much more easier, like VirtualBox. This is like, I have an operating system, and on top I have VirtualBox, hypervisor type 2, and then my applications. And in the image, it's probably easier to understand. Hardware, hypervisor type 1, whatever you want on top. For example, different operating systems. And in the type 2 hardware, some operating system, and then hypervisor like VirtualBox, and then OS, okay? Clear? No? Yes? Something like that. So, impact on security. When we are talking about security, virtualization is actually quite of good. Like, mainly we use because we can isolate processes. So you can give a process a special memory section. You can give a process access to actually one CPU and not every CPU. You can give a process completely separate things, and that crazy increase the security, right? If one operating system, if one application is attacked by buffer overflow, well, it's not affecting others. You can separate your database, you can separate many things. You can do containment of processes, which means that these processes, if they are vulnerable, if they're attacked, and they try to attack others, they cannot. So it's kind of going with isolation. In isolation, you just separate them. Containment is like, oh, you're trying to break free. I'm not going to allow you to break free. By the way, in a lot of virtualization technologies, you can break free if you exploit the virtualization, but we are not going to go there. The other nice things about virtualization is that I can roll out, so you can freeze the virtual machine, and you can store it, and you can recover later, like in VirtualBox, like in Docker. So you can say, oh, you delete all the database? No problem. I can just bring the backup, roll back, and have the database again. That's probably one of the best reasons why to use virtualizations, right? And also it's easier to secure and easier to apply policies, right? Why? Well, because this is a small system. Because virtual machines are smaller usually. In Docker, you can run one Python application. So it's so simple that it's very easy to secure. You have no users, no logout, nothing. If you need to secure a whole computer, you already did that the classes before, remember, right? Attacking and defending computers. So the impact on security is great. Who can tell me, for another ghost or whistle, you can choose, who are the largest users of virtualization technologies right now? Who are the largest in number of virtualized technologies right now. As a concept, I don't want names, unless you have names. Server, what is a server provider? What is a service provider? That you give me more details. It's a little bit vague. And he wants to answer, but he has the opportunity. He has the opportunity. You have one more. Go. And how do you call these companies? You are so close. You did the very nice. I'm going to answer what you say for the video. You say that there is companies that you can have service providers, and you can go and install your own operating system or computer in these service providers. That's true. We give a name to these ones. Okay. Docker. Docker is the product. Docker is virtualization, but Docker is a product. I want to know who. Containers are what you create with Docker. I want to know the type of organization very close that actually uses, for example, Docker the most. Other technologies too for virtualizations. Wait. Okay, that's when we go to the internet. Cloud services, there you go. You have a ghost for you. Cloud services, people. All the cloud is virtualization. Whatever you want to call it. I'm not sure which is the biggest one. Is DigitalOcean, is Google Cloud, Azure, Linux, I don't know, whatever. Like, these are hundreds of thousands of virtual computers, virtual networks, virtual memory, virtual everything. So, yes, that is the biggest uses of these ones. So, virtualizations versus containers. Who can tell me a little bit what are the difference between virtualizations and containers? And I have a whistle right now. You want to keep them? The last one, the last whistle ever in the history of whistles. Who can tell me difference between virtualization and containers, or containment, I need to say. Virtualization, containment. That's good, that's good. Containment is a way of virtualizations and repeating, yeah. I like it, but why then the container is higher? What is higher for you? Yes, sorry, I will paraphrase. Containers, you say, like are higher and only the applications running, but higher level of abstraction. And then the virtual machines are usually larger, holding more things, operating system. Perfect. So virtual machines usually more generalized, and containers are usually for a specific purpose, right? And that means that exactly that was they were created. They were created because you want to containerize one application, two applications. You want to start 20 Dockers or 10 or 100 very fast. I don't want this in a virtual machine. I don't want in the virtual machine to configure the network, install, it's like too much. Like for example, in Dockers or in other containers, you can create and stop them, very nice, communicate, very lightweight, okay? Okay, Lucas, there you go. 1, 2, 3, are you ready? I'm gonna try to, no, this is better this way. Ready? Almost. I think mistakes were done both ways, but, okay, so Before getting into containers and virtualizations, we can do our second break of the day. 34, we are back at 44. 10 minutes, internet, go to the kitchen and get another beer. I'm not sure. I don't know what to do, what I want. See you in 10 minutes. Okay, we ready, people? You back, internet? Ahoy, internet. Back. Go back, internet. So, virtualizations versus containers. Containers are called the lightweight virtualizations, like we said before. They are very fast, and usually it's kind of a sandboxing. It's like containment of processes. And directories, we don't do it by hand. And here is an example of the difference between, for example, what both Docker engine and a hypervisor of type 2 are running on top of the OS, right? So the VMs are virtualizing the full guest operating system. This is kind of VirtualBox. And in the case of Docker engine, you just share a very small amount of things, like libraries and binaries, and then all the applications run on top, okay? So this is a huge difference. And by the way, when Docker was created, it was like crazy awesome technology. Everyone was like, oh, what are Dockers? Oh, we have no idea. It's like beautiful. So let's use this technology. I mean, you are using Dockers in our network for a long time, but you are not creating them. So let's use Dockers to actually create computers for you, and let's execute malware, people. So the third big thing of the class, after all the attacks, is we are going to execute malware. Well, you are going to execute malware inside your Docker, because it's going to be contained, it's going to be isolated, and it's going to be safer, at least for you. So how do we do that? We are going to be using something called the playwithdocker.com. To use playwithdocker.com, you have to log in. To log in, you need to have an account in docker.com. So if you... Well, yeah, or GitHub or Google. But actually, when I try all the time is GitHub or Google to log into docker.com. So go there, get an account in docker.com with GitHub, with Google, or whatever. And when you have that, we told you before to have them, let's play with Docker. So I'm going to get into Labs Play with Docker. Looks like that. Internet 2, please go to Play with Docker. I'm going to give you 20 seconds to get an account. OK, 10 seconds to get an account, and click on yes, take all my money, take all my everything, go. You have credit cards? Yes, credit cards. And now that you have your account, you press Start in Play with Docker. Internet 2. Everybody's OK? Are you in already? Yes? No? Maybe? Yes? You don't know? Looks like? Yes? Perfect. So when you get into Play with Docker, you will have your connection for 4 hours for free. So you are ready to create your first instance. So to create your first instance, you click on Add New Instance, and this is going to create for you inside Play with Docker a machine for you to play. Okay? So, a little bit complex. Actually, this Docker instance is going to be running an Ubuntu OS, and what we want to do is a little bit complex, because you're in your computer, that is actually in your browser, that you are in your VM, and in your VM, you're going to be creating a Docker instance. So this is kind of a complex situation of where are you really? It's like, yeah, in many places at once. So yeah, we need to go deeper in this one. And how we do that? Well, let's create a Docker inside this virtualized environment. So, wait for me. Docker is the command line for Docker. Run means run a new instance. We are going to connect to the network of the host, and we are going to give the -it, which means interactive terminal. Interactive terminal, right? That IET is terminal, and -i is interactive. And then we are going to be running a version of Ubuntu. That's the name of the operating system that we are going to put inside Docker. And when the Ubuntu is ready, we're going to execute bin bash. That is going to be our shell. Okay? So this command creates, with Docker, a new container running Ubuntu, and you are going to be connected to it. Okay? So this is the play on Docker virtual machine. You pass the command, and inside the virtual machine, we are going to create an Ubuntu Docker. I'm going to try to see if I can make this now. So everybody, I will wait for you.
Did anybody here got we ran out of capacity message? No? Great. So online, if you are doing this live and you get a capacity, how is the message? Capacity and cannot create a session at the moment, try to refresh, and it should work, okay? It's too many of us, but they should be able to host us.
Yeah, I'm again impressed that whatever service we touch, we are pushing the limits. I have no idea who is running this or how, but yeah. If you are looking at this class and you are the owner of this site, first, thank you very much. And second, I'm sorry for using all your resources. But it's a wonderful site. We super appreciate it to be able to play like this online. So look at that. Now I'm root in node 1. This is the Docker Ubuntu on their VM, on my browser, on my computer. Okay? So a lot of things going on in here. Now that we are in there, we are going to prepare to execute a suspicious file. Okay, people? Imagine that you are a security researcher. Imagine that you receive a malware, suspicious file, maybe a benign file that you don't know, and you need to execute it. Are you going to execute this in your computer? No, right? Are you going to execute this in your friend's computer? Maybe, but that's not the point. The point is to have an environment that you can analyze this freely and safely. So you are going to prepare to execute malware in this Docker. First, do the apt update, please. So we update the packages in Ubuntu. After updating the packages, we are going to install some of them, ping and others. So just copy the command and install internet, all the things. Install, install, install. Perfect, thank you very much. And after that, we are going to create a Tmax. Okay, not now, later. I'm installing, taking some time. Thank you for the bandwidth. Play with Docker. I will give you some seconds for yours to finish. How are you doing? Good? Percentage? No? 80, 90, 50? Anyone finish? So I finish, I install some things, okay? Now I'm going to create a Tmax to get into the capture of the traffic. If you remember from the exercise before, every time we do anything weird, we are capturing the traffic. We want to capture in a pickup, we want to monitor in real time, and then we want to do whatever we need to do. So we are just repeating the steps. Now, with Tmax, I'm in a new Tmax. And yes, we are in a computer, Nasdaravi, in a browser, in a VM, in a Docker, in a Tmax. It's getting complex. It's getting complex. Just be careful where you press Control D or you delete stuff. Now that we are here, we are going to execute TCP dump as before, nothing new for you. And this TCP dump is going to store the packets in /tmp capture.pickup, so you can later analyze this at your leisure. I'm going to get out of the Tmax, so we let it run. Now,
can we hold a minute? Because there is some delays in starting the Docker, and some people are behind.
No problem. How are you doing, people? Are you delayed? Did you start? No? Are you with the Docker running and TCP dump already? Hands up. The other hand, I'm not. I'm having issues, trouble. I'm not sure why I'm here. Got you. Both, in that order. I'm giving you some seconds for the install to finish. So now that we have this, we can create the next Tmax that is for the monitoring. Remember? There you go. We are going to be doing the same TCP dump, but now we are going to be doing it without the storing. Okay? That's it. Super good. You get out. Control-VD. Now, we are going to be creating the Tmax for the execution of this probably malicious file. And we are going to be calling this Tmax session test. Can we call it malware execution? Yes, sure, but we're a little bit paranoid. You know, people can be watching us. They are always watching us, especially in a live class. So we are smart, and we call it test. So now that we have this, we are going to be downloading some malware files. We are not going to go now how to get the malware files. There are many sites we can tell you later. Today we are going to see some of them. For some weird reasons, you got malware files. Like you can go to urlquery.com and others and get some of them. This is going to be the one we are going to be using today. So it's malware file that it's getting from some site. In this case, was found in a drive. And we are going to download this, and we are going to call it suspicious file because, well, we don't know the content, right? So there you go. We download something called suspicious file. You can check that you have it, and it's here. Okay, everybody? Don't download this in your real computer, please. So now that we are here, you can use the command call file to actually give information about that file. And it's saying, hey, file suspicious file. This is an ELF. That's the standard of the execution binary files for Linux. So if you have anything that is compiled and running for Linux, the format is called ELF. It's a 64 bits, a lot of things, versions, okay, whatever. Okay? You have it? I'm giving you time. Internet, an issue, you tell us. Now, to execute it, actually, we need to give execution permissions. That means, again, 7, read, write, execute for the user owner. Second 7, read, write, and execute for the group owner. Third 7, read, write, and execute for the rest of the owner. 4, 2, 1. 4 plus 2 plus 1. 7. Okay? So if you do that, then the file now is executable, and we are ready to execute. So, --, execute suspicious file, enter. There you go, ta-da, we have something. I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. Who I'm quoting for the ghost? Well, the malware is quoting. There you go, Dune. Well done. The book, not the movie. Well done. So there you go. We have something running. It's it take the terminal, pay attention, so I cannot keep typing here. It doesn't matter because we are smart and we're in a Tmax. So Control BD, let it run, Control BD, and now you can go to your monitor. You can go to your monitor and press enter. Oh, look, we have traffic. Actually, this is a little bit small. Sorry. Oh, there you go. We have stuff. Do you have stuff? Do you see stuff happening in your monitor or not? Yes. No. Oh, there you go. Yes. Oh, well done, people. You were successfully infected. Well, not you, the computer, but well done. The real thing. And look, it's like, oh, we have like network interfaces, and there was something more. I can go up. If you want to go up in Tmux, it's Control V, square brackets. I will put it here. If you want to go back up in Tmux, you can do this. Control B, square bracket. That is to go up and down in the scroll. If you just want to scroll. I can go up and down now with the mouse and find things, and you can see packets and more interfaces, and this looks like the open ports in my computer and some oh, there are commands, see? Some commands. Something is going on. I don't know what is this. Another netstat. Unames is getting the name of the computer. There you go, people. And then Control C to go back to not scrolling. So this is how you can use virtualization to safely execute something without needing to do something in your computer. You don't care, right? So now that you find this and you know it's working, that's it. You have the pickup, so you can actually go back. I will keep the monitoring, but I will, let me try to make this bigger for you. I will go back to the test, and you can press Control C if you want, so you stop executing. Let me go down somehow. Can I? Oh, there you go. And then you have the pickup in TMP, so you can copy back, you can send to some place, whatever you need in there. And then you analyze the malware, you execute. And what you do when you finish? Do I need to, I don't know, delete files? Do I need to do something? I do not. If you want to finish this, you just stop the instance. In this case, it's the delete. So in Docker, you just stop the Docker. In here, you delete the Docker, delete everything, and bye-bye.
I have a better idea. What happens if you do, finally, you do rm-rf-.
rm, Veronica proposed to delete the whole computer. Did you ever want to delete your whole computer? Do you have this feeling from time to time?
Every Monday morning.
Every Monday morning. It's very common. We have a name, a condition for this. I just want to delete everything. So let's do it. Why? Not in your computer, please. Be sure that you are in here. rm rf/. Are you ready for this?
Make sure this is in plain Docker and not on your Docker CTO students, please.
Yeah. If not, it's the last command you do, like literally. That's it. I'm going to delete everything. Oh, yeah. Oh, I need to. It's telling me, are you sure? Yes, I'm sure. No, preserve, root. Oh, there you go. Yes. This is therapeutic, people. This is like punching your pillow. Take that, computer. You don't like me, I don't like you. Yeah. So
this is interesting because there is a lot of situations. If you're a prepper or you are into that, and you say like, oh, I'm doing something, and then I hear a knock in the door, 3 a.m., right? And then you say like, oh, I need to delete my files. It's not going to be that fast, right? It's gonna take a while. Yeah. So it's actually a good idea to kind of try the things, and this is why containers are a great thing.
And look, I cannot even type anymore because I don't have nothing to type. Oh, so nice. Oof, that feels better. Now that we did this, we can delete the instance. So go delete the instance, 1, 2, 3. deleting the instance. Well, if you took the pickup out, I didn't. It's going to take some time. I hope we didn't break the site. If we break your site, I'm sorry. I'm going to get you a new one later. So let it delete itself. It's fine. Did it work for you, everybody? How did you feel executing malware? Was it not amazing? No? You can get any malware, any phishing link anybody ever sent to you and just go there and click. Oh, yes. This is spam from this Nigerian prince. Yes, click, and you see what's going on. This is opportunity, people. Yeah, you can have a job doing this, actually. So that's how we are going to be stopping with the part of virtualization. If you cannot capture everything, we have some capture files for you to download from here, there, in case you need. And to do a small recap in virtualization, virtualization can actually help you much better to secure everything you have from your defenses, minimizing the complexity, separating processes, separating malware, network, disk. And it can actually, in our work, cybersecurity helps you investigate and execute malware much, much faster and better. In the Stratosphere Lab, we have several laboratories executing malware. All of these ones doing something similar, right? We have IoT, malware execution, Mac, Android, iOS, and many others doing these techniques, okay? So, I will give you some resting time in the recap, and it's password time. So slowly I will go to the password time. Today is class number 7, right? Number 7, firewall. Internet, this is your password for the class today. Firewall. And you are done. So, now that we are after the virtualization, let's jump into the last topic of this class. It's going to be threat intelligence, people, and it's going to be the fourth nice thing that we are doing today. For the last ghost ever, what is threat intelligence? I know you know. Oh, that's actually not a bad answer. It's not the correct one. What we learn in class, sorry, about threats. We learn about threats, but okay, well, is it? I will go with a maybe. What do we learn about threats, for example? Then I would have to say no. I say like vulnerabilities in protocols. Vulnerabilities in protocols are good, they are threats, but that's not the threat intelligence we want to learn. Go, Lukashi. But thank you for playing. Yeah, go. Okay, I like that. So we are saying that you are checking in your computer, in your network, what's going on, what's happening, if there are things, packets, I guess, or something, going and coming. And what else you said? What's happening? If it's a threat or not. That's good, and we also do that kind of detection, right? Oh, there is something going on, is an attack or not? That's good. I will go with probably it's not threat intelligence. You can use that to create threat intelligence, but the fact that you detect something, it's not directly threat intelligence. It's a little bit blurry because you can use threat intelligence. Then I will go with no, because you look at something that you don't know, and they say, hey, are you a threat or not? And then you find a way. That, I would say, how would we call that? Threat hunting? incident handling, when you see some detection and you are trying to find out in your network if it's an attack or not. Incident handling, no. Incident handling, you never know. You know it's an incident. Threat hunting, I will go with threat hunting. Yeah. True story. And you can do that, like if people can get into a room that it should not, right? I will put that into the more penetration testing, like, hey, I need somebody to test if there are risks or threats in my building, for example, and that is a risk, and that's something you need to address. It's not a threat because there is nobody actually taking advantage of it. The threat would be if you know somebody that may go and open the door. And then it's like, hey, having this person here is a threat for some reason. So that's not. Who else? Threat intelligence, yeah. Who else can tell us for a ghost, I want to go home? Who can tell me? Poor ghost, look. Threat intelligence. Threat intelligence? No? Okay. Threat intelligence, I'm sorry, ghost, I try. Threat intelligence, it's the use of the knowledge, of the information from the community about the threat actors. So we have knowledge coming from data, information, you convert into knowledge from the community about the threat actors. Who is attacking you? The technologies they are using, the infrastructure they are using, the tactics, the procedures. Threat intelligence is anything that you learn from the past attacks so you can help stop future attacks. Is it clear? Threat intelligence is everything we learn from past attackers, attacking others maybe, that I can use to protect myself. I may not see it now, I may never see it, they are not in my network maybe, but I can learn from them and protect myself. Okay?
In the analogy, sorry.
What's the difference between just the experience?
So the issue with the personal experience is that if you go to your network and you see something, you need to analyze. So you analyze. You may not know what it is. If you find that that's an attack, that's good. Now you can take that and share your threat intelligence with others. Say, hey, these actors are using this port to attack. Block that port or something, right? The difference is that if you have previous threat intelligence, you know in advance, hey, that IP you should block because it's some attacker from Argentina. So even before you see it, you can go and block. So when they attack you, they're not getting in, right?
Going back to the analogy of physical applications, if you want to protect a room server, threat intelligence in this case could be, for instance, there is a band of robbers breaking into servers, and they are using digital readers to break into the security pad, right? So this is the intelligence that you get because you have friends having business on server rooms, and this is a type of information and knowledge that can tell you, oh, I have to put additional logs, I have to put additional security, I have to install a camera to look, because I know that this may affect me. So this is kind of the going in that way.
Yeah. You learn that somebody break into your neighbors, breaking the window, and then you put bars in your window, roughly, okay? So threat intelligence is information to aid decisions, and the decisions may be to prevent an attack, to reduce the time to discovery, to understand the threat landscape, to better make better decisions. So there are some types. Go with me. This is the last theoretical part of the class. We say that some threat intelligence is strategic when this information is for the long term in a very high level view. High level, long term. Strategic threat intelligence helps you make long-term plans. So I put some examples here. For example, the Interpol report on new threats during COVID, that was a very high-level report that helps you take decisions in your long-term planning. They are attacking hospitals. They are using this and that. You better put money in protecting, I don't know, your RX machine, right? This is strategic, long-term planning, you need help. The second one is the tactical one. That is still long-term, but now it's a little bit lower level. So in the tactical, the example is like, this is a general defense improvements that you do based on known behaviors. So now the example is the meta-analysis of emotet malware. This one is, hey, we know the emotet malware, and all the emotet malware behaves like this. I'm talking about a specific one. And then because you have the known behavior, now I can do defense improvements. This is more low level. I'm talking about emotet things, but this is a little bit more high level in, long-term in the decisions. Then we have the operational threat intelligence. The operational threat intelligence is like short-term, very fast, but still high level. The example here is, the example here is, for example, if you are a financial institution, imagine you're a bank, you can check the CISA report on the North Korea targeting fintech, the financial technology sectors. So you say, oh, wait, we have this type of information that is how the financial organizations are being attacked. I care about this. But this is immediate response. This means right now, there is people attacking, maybe attacking you right now. This is an active situation. This is low level. We are not talking about plans here. We are talking, they can be attacking you tomorrow morning. There is no more time for planning. This is go right now. However, the information that you have is still high level. Some state sponsor attacking fintech. You cannot act on this information immediately, but this is operational. The last one is the technical threat intelligence, when you have very short term, very low level. And this is what we call mostly the indicators of compromise. So the example is, I am tracking a botnet, and every IP address, every domain they are using, I'm putting in a list. All of these things, IP addresses, domain, we call indicators of compromise, IOCs. That means if you find this, you know you are compromised. And then you need to go and put this in your firewall directly. Get IP and block it. That is a technical threat intelligence, okay? So going back to indicators of compromise, these technical details, information like IP addresses, domain, hostnames, URLs, whatever. You use this to build intelligence. Usually humans verify these ones. And if you have bad verification, that's tough, people. If you are a human saying, oh, that is emotet, and it's not, you're going to have very, very high issue, okay? So the thing I want to say about threat intelligence is the following. Right now, as a community, in the world of cybersecurity, we have a lot of things, right? We have AI, we have antiviruses, we have firewalls, we have a lot of things. The most used technology as a community in the world that we have right now is threat intelligence list, IOCs, IP addresses, and domains that we just get from the internet. This is right now the top used technology to stop attackers, which is a little bit sad, right? The best we can do is list of IP addresses. It's like, yeah, we have machine learning-based detection. Yes, it works, but few people is using this, and the impact is kind of small yet. The majority of people is just downloading IPs and domains, putting in firewalls, putting in proxies, and stopping everybody, which it may not work. So how do you find threat intelligence? In many ways. There are sites like these ones, Abuse IDP and AlienBot, that we are not going to go there. We are going to be using VirusTotal. VirusTotal, originally an independent company and owned by Google since the last 10 years or something. It's the most crazy, biggest, largest site to analyze, search, and find information about threat intelligence and malware ever. This is the place where everybody's uploading malware samples, and you have all the antiviruses ever possible analyzing this for you, and we are going to be using it, okay? So we are going to start with this one, and this is the place that the majority of the threat intelligence can be found. So how do we use it? We have here an IP address, 1111, and I'm going to go to VirusTotal, and I'm going to say, can you search 1111? And then you press enter. Too much. And then you press enter, and it's telling you, oh, one of 19 security vendors flagged this IP as malicious. And then you have the list of vendors. It's malicious for ThreatHive, ArcSight says it's suspicious, and then you have everybody here. Like you have, I don't know, S-Security, G-Data, Kaspersky, all the security vendors, Sophos are here. And yeah, Cyan, Lumu, Netcraft. And so who can tell me now for the ghost, go for the ghost, who is the owner of 1111? What is that IP? Why you should know it? What is 1111? Cloudflare DNS, probably one of the top DNS used in the world, right? We know this is not malicious, people. I mean, it's Cloudflare, everyone uses it. Like, why it's marked there as malicious? Lukashi, there you go. Javi, 1, 2, 3. We can do this, Lukashi. Are you sure? Are you ready? Go. There you go. Hui. This. If you don't put the intention, Lucas, it's gonna be very hard in here. Sorry. So why we see this one in here? Yeah, why we see a one malicious red bad of one of the top 5 IPs used in the world? Well, I don't know, but I guess that is because these companies are analyzing a lot of traffic, I guess traffic from malware, and malware uses 1111, like I use like you use 1111. So they wrongly believe that because the malware connects there, maybe it's malicious. So be careful. The moral of the story here, be careful when you use threat intelligence. Even companies like this can be wrong, okay? So go to this one. I will give this to you. Take 10 seconds, 20 seconds. Take that. That is the hash SHA-256, the SHA of a file. That is the identification of a file. Go to VirusTotal, search that, and tell me if it's benign or malicious. Internet, I'm waiting for you too. Benign or malicious? What do you say, Internet? So, I'm not sure about you. I would say probably malicious. 26 out of 59 security vendors flag this as malicious. And they say exploit agent, agent, shell, exploit, Trojan, chain shot. And so most probably it's malicious. It's impressive that not everybody detects this as malicious. Maybe you are using one of these software. I don't know. And you can see the details, right? The history of the file. You can see what the community said about it and others, okay? So this one, most probably some malicious file. What about this IP? What can you tell me about this one? Let's go and do this one. What do you say? And if you pay attention, the detection is never 100%, right? So 13 said that this is malicious, and it's actually already detected. Huh? It's malicious, confirmed to be related to Mirai and Mossy. The problem is that these IPs rotate. So maybe it was malicious, I don't know when it says here, 1 year ago, but maybe not anymore. So this is why sometimes the detections come and go, okay? Let's go to the next one. What about this one? What can you tell me about the second hash? How do you know? The community, look at the community score. The community says minus 696 votes down. But why is 0 then? So if you read the comments in the community, you will find people, it's like malicious, 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 malicious. But then you will find people saying, hey, nobody noticed that this is actually an empty file. If you go and see, it's like, not empty, sorry, an empty file, an HTML file. So it's very small, 1 kilogram. I'm already tired. 1 kilobyte. Well, I don't know the weight, but it weighs something, right? It's not 0. There is electricity here. So 1 kilobyte is an HTML. And actually, if you see the details of the HTML, the content is 404 not found. So this is an HTML, but it's a page saying not found. But so many malware connected to this page, so many malicious things that loaded this 404 that everybody that was executing malware say, I saw this in my malware, this is a malicious file. Well, yeah, maybe malicious who access, but the file is not malicious. It's a 404, right? So again, be careful with your threat intelligence. Okay, so, and this is why we have things like the MIST project. MIST project is an amazingly crazy good project to actually have these servers where everybody can go and share the threat intelligence and comment and put new things on each other, okay? So there are some limitations on the threat intelligence. To start is that you can detect the past, but you cannot detect the future people because it's threat intelligence. It's whatever we saw. So whatever is new is not going to appear there, okay? You have very good information about things like command and controls, and all ones, but that's it. Everything all is good. There is not much information about small malicious campaigns. New things do not appear. And it's not exhaustive. Like sometimes you have IP addresses, a malware connecting to 1,000 IP addresses, but only 10 appear here. Okay, so it's a guide. It's not everything. And of course, you can have false positives like we just saw. So we are going to end up today with generating our own threat intelligence. This is very nice. You are going to have your own attacks, in the future your own honeypots, whatever you want. How do you create the threat intelligence out of this? How do you have this to share with the community or with your firewall? And for this, we are going to be using a tool called AIP. AIP, Attacker IP Prioritizer, is a tool that we created in the Stratosphere laboratory and helps create your own threat intelligence based on your own data. Quite unique, I have to add. So the key part is that it uses several statistical models to actually create very short blacklists that are very efficient. So every IP address that it's in there for you to block, I want to be very, very, very sure that it's actually an attacker. So there are several models, I will tell you now, that helps create the list with a score, and the score gives a priority of the higher the score, the more attacker is the attacker, okay? And this is good for you to actually evaluate. So let's create it, people. The way it works right now is that you have Zig logs, and these Zig logs are your input. Zig logs is a type of network flow. And then you have here the identification of the attack. You aggregate. This is inside the Python of AIP. Then there is a cache. Then there are all the models. Then there is the post-processing of the block list and the generation of the block list, okay? This is how it works. So let's create some of these. And look at such a nice progress bar that Veronica put here. We are in the installation of AIP. So what is the goal? The goal is that we are going to get Zig flow data from some honeypots. We are going to see these attacks, and we are going to extract IOCs using AIP, okay? So log in your Dockers or the Stratos Cyberlab. Be sure, Stratos Cyberlab people, that you are not in any SSH. So if I go to my thingies, I could be in the Hacker Lab. That's good. Now, please git clone the AIP. Go and we'll get out of here. Git clone the AIP. Get out of here. Yes, get out, get out. I'm going to go and clone my AIP. Perfect. Now that you clone it, get in the folder of AIP. Okay? Huh? And now apt install the Python environment. You don't need this in so much in CVUT, but it's fine. We can do this. This is because the libraries needs an environment. Get into the, create environment. There you go. When the environment is created, you can activate it with the source, like you did so many times. There you go. We are in the Python environment. There you go. Now install the requirements for the tool. Okay. It's going to install. And now you need to export to the Python path where our libraries are, so the tool can run. And finally, we can see the help of the tool and confirm that the tool is working. Okay, just execute the help, and let's see if it works. I'm also going to run in the Stratos Cyberlab. There you go. The tool is running. Okay, everybody? Is the tool running for you? Not yet? I will get for you, internet. I hope it's working for you. If not, you can tell me. Perfect. You should see this change in the help. Perfect. You have it ready? Yes? Perfect. Now that we have installed AIP, you can see in the progress bar that we are preparing the data. And for that, we are going to be downloading specific files of a honeypot. These are real attacks to real honeypots. We are giving you the data, so because we don't want to wait, 3 days for you to get the data. So these are real Zig logs that you are going to be downloading. So please download. There you go. Perfect. Now that we have this tar file compressed, we need to uncompress and untar. If you do not know tar, we already talked about this, a program to kind of bundle together files. So we are going to unbundle the files and uncompress with this command. X means to untar, V is verbose, and F is the file we are giving. So there you go. Should open the files. And if you list the files in data raw, you should see the files. So please confirm that when you do the ls of data raw, you see the files. As you can see, we have many days and 4 days, and each day has 24 hours, and each hour is a file. One file, 1 hour of logs, okay? And you can actually see those logs. There's a lot of information there, right? If you do data, raw, sum to something, what do you have? 10.03, and then some file. I'm just picking some random thing for you to see, and see you have flows. Flows, okay? So now we have many flows. Let's use AIP to actually create the list for us. So edit the file called honeypot public IPs. This is to ignore some files, because some IPs. Some IPs, like the IP that you are using to administer the honeypots, you want to delete. So go into this file and create with this content. Create exactly with this content. This is the correct IPs to ignore in these files we gave you, okay? So I'm going to create this one, honeypot public IPs. No. Get up. No. I already have it. And then you also need a file called do not block these IPs. This is because some IPs we do not want to appear in the final blacklist. This is kind of a whitelist, we call them. Like, yeah, ignore these ones, okay? It's always good to have IPs that you want to ignore. So please ignore these two IPs. Be careful with the comma at the end. The comma should be there. Okay? Everybody? I'm going to give you some seconds. You ready? Yes? Perfect. So we are ready to run. That means that we can say AIP, verbose mode, go and run. And when it runs, it should start analyzing these files. I want to explain what it's doing behind the scenes. And it's computing the models, and then creating the blacklist for you. Okay? So also online. This should work. There you go. And that's it. Run for you. No errors? Awesome, nice. So let's see what happened here before the list. So let's take a look at the list while I explain to you how the model works, okay? So the lists are compressed. They are CSV, but they are compressed. So you can use compress less, zless is like the less for compressed files. If you do this command, you will see a list of IP addresses, comma, and a score, okay? Do you have lists like these ones? So let me tell you very fast how does it work. There are 4 models. This model is called the prioritize new IPs. That means that this tool is looking at all the days in the past, keeping track of all the IPs, and every time that there is a new attack from an IP, that is the first time ever that we see this IP, your score goes up. If the same IP attacks tomorrow, the score goes down. If attacks against, down. If it's a new IP attacking, up. That means it's focusing on IPs that you never saw before, but they are kind of attacking you more. That means like IoT devices, special things, okay? The other model, called consistent IP, this one is the opposite. This one gives more score to the IPs that consistently attack you. Every IP that is attacking you every day, the score goes up. If an IP stops attacking you, goes down. So this modifies the list to prioritize those that are much, much more attacking you, okay? So you have different focuses. Do you want to focus on the very good old attackers, or do you want to focus on the new attackers? 2 different lists. And then we have the alpha model. Alpha model is just everyone that attacked you yesterday. Very simple. And the alpha 7 is everyone that attacked you in the last 7 days. Okay, very simple ones. So, and then we have a random forest, because actually there is a little bit of small machine learning here. The random forest actually, it's a model trained, getting the flows, getting the packets, getting the duration, and prioritizing those that, according to the model, are better attackers, right? So if you want to see the random forest ones, you can see the listing here. By the way, parentheses, this is the first tool ever that we know as a research that actually uses machine learning to have better threat intelligence feeds, as we know. The companies are just getting the list, mixing them or making them better, but that's what I know. So what about these IPs? Look at this one. We have an IP, and this one is the top in the score, 018. So we can check. So let's go to virus total. Let's put it there, and we can check. And look at that. 11 out of 94 is some IP from Turkey, I believe. Yes, TR. And it's malicious by a lot of others. So we are not the first ones to see this one, right? I can take another one here. So these are real IPs of real attackers to our honeypots, right? And this one is from France, 14 of 94, and many, many, many others, okay? So Now you can analyze these ones. I will go to the random forest. I will go to the random forest one. If you go to the random forest, you will see that there is no score because how the model works is just classifying. I'm going to take the first one. And if I go to values total and I put the first one, you will see that it's marked as benign. This is from type 1. This is because this model is finding kind of things that are unusual. So this is not a consistent attacker. This is not your typical mirror. This is an attacker that, well, was never shown before, right? So this is kind of nice. So let's do the recap. Threat intelligence is by far the best defense that the world has right now, unfortunately. It can help prevent and detect attacks, improve decision makings, reduce the cybersecurity costs for sure. And AIP is the tool that we offer for free to the world as free software to create threat intelligence using statistical models to better create feeds, okay? So I'm going to close up in the threat intelligence chapter. We saw many things today. Man-in-the-middle poisoning, NetBIOS poisoning. We did the malware execution, threat intelligence, so many things. And we are ready to close. So this week, there is no assignment. Oh no, boo, right? Boo, no, yeah, boo. There is no assignment for you, so you can take a rest. Also, online people, there is no extra challenge for you, so you can go and rest this week or catch up with other things. And I will give a moment for questions. Things that didn't work, things that work, threat intelligence, AIP.
I just want to do one more reminder that the first assignments 2 to 5 are closing tonight at midnight Prague time. So if you still are working on those, this is the last moment to finish up. We will stop the containers, and also in CTFD, we will not be able to submit the flags after midnight.
And I want to add to that, thank you, is that we cannot ensure everything is not going to break, right? So don't wait until quarter to midnight to solve something, because if it breaks, we will not be awake. So just try to do it in as soon as possible.
Okay, if there are no questions, people, that's it. See you next week, and have a beautiful weekend, and bye-bye. Bye-bye, bye-bye. Ciao, Internet. Thank you very much for staying. Yes, and remember the feedback, people, Internet. Feedback, feedback, feedback. Thank you.